I'm Shamika Agrawal.
I'm Shirina Agrawal.
I'm Ladan Hashi.
I'm Gabriella Milgram.
And I'm Prayag Sreenivasan.
And our project was on the new prebiotic compounds found in the Murchison meteorite. The Murchison meteorite fell near Murchison, Australia in 1969, and it's significant because it was collected soon after its fall, which meant that there was no contamination from Earth. So the amino acids and nucleobases that were found were extraterrestrial, and it was a higher likelihood of it being so. We conducted our research by looking at multiple scholarly articles and scientific studies, and we came to the conclusion that there are over 100 prebiotic compounds in the meteorite. The composition of these compounds suggests that they were not formed in the conditions possible on Earth, and this provides a better understanding of the formation mechanisms of amino acids.
Our research focused on the Murchison meteorite, which fell in 1969 in Australia. This carbonaceous chondrite is significant in the field of astrobiology because inside the meteorite, scientists found two important prebiotic compounds: amino acids, the building blocks of proteins, and nucleobases, an essential component of nucleic acids like DNA. Some of these compounds have not previously been found on Earth, prompting questions about the possibility of extraterrestrial life and the origins of life on Earth.
From our research, we found 96 different amino acids and 8 purine nucleobases that have been identified by name in the Murchison meteorite. Glycine was the most abundant amino acid found, followed by alanine, hypoxanthine, isovaline, beta-alanine, and 2-amino isobutyric acid. As shown in our graph, guanine was the most common nucleobase, and it had the highest concentration, with 72 parts per billion, and it was followed by xanthine, adenine, isoguanine, purine, and 2,6-diaminopurine. There have also been 6 new diamino acids recently found in the Murchison meteorite, making it the first time diamino acids were discovered in a meteorite. The 6 concentrations in the meteorite are listed in parts per billion.
All the research we pulled data from used the same data set. This data set was created by isolating the amino acids within the Murchison meteorite and measuring their concentrations. What those researchers did is they took a core sample of that and then tried to remove the impurities mixed in by boiling it in water for 20 hours. Whatever was left over, the pure stuff, was powdered and then subjected to acid hydrolysis, which left behind the precipitate of impurities while the actual amino acids were dissolved. Further organic material was removed by dissolving it in diethyl ether and then removing that. The salts that formed from the acid reaction were taken out in an ion column. And then finally, the remaining amino acids were converted into isopropyl derivatives and subjected to gas spectroscopy, which differentiates them based on boiling point.
In conclusion, the molecular composition of the amino acids on the Murchison meteorite demonstrates that they are of extraterrestrial origin. Discovering an excess of left-handed amino acids on the Murchison meteorite also serves as evidence for the theory that amino acids delivered by asteroids or comets to the early Earth contributed to the origin of only left-handed base protein life. Comprehending the origins of life on Earth provides a new basis for the search for extraterrestrial life. The amino acids on the Murchison meteorite must have also used other formation mechanisms in addition to the Strucker reaction. Future studies may focus on how these amino acids formed or examine further into how meteorites may have carried prebiotic organic molecules to primitive Earth.
We would like to thank Margaret Beggio, Selena Miller, the NASA TSGC team, Suzanne Foxworth, and all the NASA ERAS speakers.
We'd also like to thank the SEAS program for the wonderful experience. We learned a lot. It truly taught us more about STEM, and now we're all more excited to go into STEM fields. And it also taught us more about teamwork and collaboration that can be used in many other applications as well. So thank you.